Good morning, students. I am Anurag of class 12. I study in class Kendriya Vidyalaya. I study in coaching named JYOTI classes. In 2 days, I have studied the chapter electromagnetic induction. Today, I am going to show that what I have learned today in this chapter, which I have studied 2 days. It's a graph of current in the AC circuit. Maximum current is obtained at this point, value pi by 2 t. We are going to derive a relation average value of current in half cycle in AC. I is the value of current, I naught is the maximum current attained by the circuit, sin is the omega t is angular, it is type of phi angular displacement, omega t, omega value 2 pi by t, frequency 1 by t. We know that current equals to current flowing in circuit is equal to charge by time, small amount of charge, small amount of time, I dt, I into dt equals to dq, integrating both sides. dq equals to I dt. For half cycle we go from 0 to t by 2, upper limit t by 2, lower limit 0. Integrating dq we get q, integrating I constant. We have written here value of I in AC I naught sin omega t, so we can write I naught sin omega t into dt, integrating I bar 0 से t by 2 sin omega t into dt equals to I bar I naught
पास बोलना है
yes
इधर ही देखना है
yes value on integrating sin omega t into dt equals to minus cos omega t by omega. Integration chapter we have learned that value of sin theta equals to minus cos theta by 2. We get cos wt by w. Now we can write q equals to I naught minus I naught.
ऊपर भी इंटरनेशनल हट जाएगा ऊपर माइनस cos ओमेगा t अपॉन ओमेगा
हाँ
इंटरनेशनल हटाइए
sin. After integrating we will write in bracket as upper limit as lower limit is given, lower limit is 0, upper limit 2 by t by 2, I naught by w minus I naught by w will, omega will also come outside, minus
because constant
cos omega t, yes, because of constant value omega will come outside, cos t by 2 by 0, putting the limit q equals to minus I naught w, upper limit cos omega t into t minus lower limit cos omega t into 0, q equals to I naught omega. Omega's value we have written 2 pi by t here we can write cos omega. In place of omega we will write 2 pi by t into t. Upper limit is given t by 2, here t by 2, minus cos omega 2 by t into t into 0. Here we can write charge equals to minus I naught omega to cancel cos omega minus cos 0 degree, cos pi minus cos 0 degree, I naught by omega, cos 180 degree value of cos pi minus 1, we write minus 1, cos 0 value of cos 0 is equals to also 1, minus 1, q equals to 2 I naught w. Here it is minus 2 and minus plus 2 I naught by w is the value of average value of current charge in the circuit. Now we will derive the average value of current in half cycle. I equals to charge by time 2 I naught by omega by t by 2. Here it will be written as 2 I naught by omega t by 2. Omega's value we will write 2 I naught 2 pi by t into t by 2, cancel 2 cancel, 2 cancel, 2 cancel, 2 I naught by pi. The value of average value, this is the derivation, I equals to 2 I naught by pi. We have obtained the derivation which we are continuing average value of current in half cycle. In half cycle there is t by 2, so we have put 0 to limit t by 2. I value of I in AC circuit I naught sin wt. I naught is the maximum current obtained in the AC circuit. As current in AC circuit has both magnitude and direction, it goes as front and back. And sin omega t angular displacement as current source displacement. Omega's value 2 pi by t. I equals we know that from chapter 1 current equals to charge by time. Small current small charge by small time. I into dt equals to dq, integrating both sides. dq equals to lower limit to upper limit I dt. I value I naught sin omega t 0 से t by 2. q equals to I naught constant बाहर 0 से t by 2 sin omega t into dt. sin omega t का इंटीग्रेशन माइनस cos omega t by omega. ओमेगा कांस्टेंट बाहर, माइनस साइन आल्सो बाहर, cos omega t 0 से t by 2, cos omega t omega's value 2 pi by t. Putting the value upper limit and lower limit, we obtained q equals to minus pi naught by w omega cos pi minus cos 0 degree. Cos pi value minus 1, cos 0 degree value 1, minus plus minus 2 into minus I naught 2 I naught by w. Charge current equals to charge by time 2 I naught by omega into time. We have for half cycle means time equals to t by 2, omega into t by 2. Omega's value 2 pi by t into t by 2, current's value 2 I naught by omega. Hope you all understand this derivation. It's the first derivation of the chapter in AC current.
Next topic.
Next we are only doing the important topic which will come in exam for exam purpose. As this chapter was only taught in 2 days and only important topics are shown in this video. RMS root mean square of current, RMS value of current, RMS value of current in AC circuit. This is the second derivation of the chapter which will likely come in exam. RMS means root mean square. We can also write this IRMS equals to under root I1 square I2 square till IN square by n 1 by n. It can also be written, the value is can be written as like that. Now we will move towards the derivation. Value of I we know I naught sine omega t. Omega's value 2 pi by t. Frequency value 1 by t. We can tell I RMS equals to 1 by t 0 से t I square into dt. This is the integration of RMS value of current in AC circuit. I RMS 1 by t I square into dt. Value of I square is given 1 by t 0 से t I naught sine omega t into dt whole square. I RMS equals to 1 upon t 0. I naught sine omega t. I naught will also come out as it is a constant. I square, it is a square, so I square sine square omega t into dt. This is the value before integration. As squares I naught square constant outside sine omega t square sine square omega t. I RMS value of current is given by I RMS I square I naught whole square by t in bracket sine square omega t equals to 1 minus cos 2 omega t by 2. The value of sine square theta 1 minus cos 2 theta by 2. The same formula we have used in case theta we have used the omega t as theta is angular displacement. In this is also angular displacement, so in cases of theta we will use omega t. I square naught 1 minus cos 2 omega t by 2 upper limit 2 t lower limit 0. I RMS equals to I square naught by 2t, 2 constant will become outside 1 minus cos 2 omega t t 0
इंटीग्रेशन का साइन
integration
ऊपर ब्रैकेट में हटेगा.
here again we will do integration. Into dt
1/2
into dt. 2 is constant, it will come outside. This value will I RMS I naught whole square by 2t 1 minus cos 2 omega t. Value we will write sin. इसका क्या था सर? 1 का हाँ यस t minus sin 2 omega t
2 omega t upon 2 omega
2 omega t upon 2 omega 0 से lower limit 0 upper limit t. I RMS I naught whole square by 2t. If we will put upper limit minus lower limit minus sin 2 omega 2 pi by t into upper limit minus lower limit sin 2 omega 2 pi by t into lower limit 0. I RMS I naught square by 2t t minus 0 t minus sin t से t cancel by 2 omega by 2 omega sin 2 pi
sin n pi 0
sin
n pi 0 पूरा 0 हो जाएगा और नीचे therefore sin n pi equal to 0 then also 0
sin
n pi
n phi
n pi 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 by 2 का pi n pi
sin pi by 2 equals to 0
sin n pi n pi equal to 0
0
यहाँ पर sin 4 by 0
sin 4 pi equals to 0 sin the value of sin 4 pi will also become 0 0 by
also 0 so 0 जाएगा तो 0
I RMS I square naught by 2t यही है ना सर we have found the division RMS root mean square I
t बचेगा
yes here will be t minus 0 t here will be t cancel we will get I square naught by 2 it will the final value and RMS whole square here it will be RMS whole square everywhere RMS square will go there I RMS will be under root I square naught by 2 which will be I naught by root 2 is the value of I current RMS I RMS equals to I naught by root 2 and by same formula V RMS will be equals to V naught by root 2 from here if we will get in numerical the value of I RMS we can find the maximum current I naught by multiplying it by root 2 and same way if we get the value of V RMS we can get the maximum voltage by multiplying it by root 2 RMS mean root mean square current will be sin omega t RMS whole square equals to 1 by t lower limit 0 upper limit t I square into dt I we will put the value of I as I naught sin omega t we will integrate it I naught whole square will become outside it as constant sin omega t whole square sin square omega t into dt I have RMS square I square omega by t dot naught by t we will put the value sin square omega t 1 minus cos 2 omega t by 2 into dt I square naught by 2t and 1 minus cos 2 will come outside as constant here it will be t minus sin 2 omega t by 2 omega upper limit minus lower limit minus upper limit minus lower limit we will get sin n phi equals to 0 sin n phi equals to 0 sin 4 pi will also become 0 and here also sin 4 pi will become 0 t minus 0 t I square naught by 2t into t tt cancelled I square naught by 2 RMS square will go there and become root I square RMS square, so this root will be cancelled and only under root 2 this will be the value of IRMS and VRMS. Hope you understand this. Circuit LC. We will study about circuit LC. Here L is inductance and C is capacitance, as we have studied in the chapter before. L inductance, C capacitance. By this line we mean in a circuit, if there will be these two things present, then what will be the direction of alternating current and the resultant voltage. This is L, this is C. This is LC circuit. LC circuit. We know that by Ohm's law, V equals to IR, current into resistance. So in a solenoid, VL equals to I into XL. XL can also be written omega C. XL value will be also omega C, as we have studied before chapter, and XC value will be 1 by omega C. We will remember this for the derivation.
XL equal to omega L.
XL equals to omega L. Omega. And here we will see. In conductance, voltage. Here voltage will be applied across the ends. So there will be two different voltage, because there are two different connected in circuit. So this is the voltage. So voltage across the ends. In conductance, voltage across VC equals to I into XC. We have learned phasor diagram. We will learn about phasor diagram. If there is only resistance in a circuit, then current I vector and voltage will be in same direction. If there is only resistance in a circuit, then current and voltage will be in same direction. In AC circuit, we know that the value of current is less than voltage, as we know that in AC circuit there can be 220 volt, but there cannot be 220 ampere, as it is divided by 2. I know in resistance, only in resistance circuit. If circuit only have resistance, then this will be the graph phasor diagram. If we have not learned the phasor diagram, we cannot obtain derivation of this circuit. If there is inductance, if there is capacitance, if a capacitor is joined in the circuit, the phasor diagram will be V. Current will be in this direction, as in capacitance the velocity, the voltage leads by pi by 2, 90 degree. In inductance, the phasor diagram will be the phasor diagram will be like this. As in inductance, current lead from voltage by pi by 2, 90 degree. These three diagrams we have to learn. If there is only resistance in a circuit, if there is only capacitance in a circuit, and if there is only inductance in a circuit. L, C, R. As we have we can see there is two things in the circuit. Now the phasor diagram of the circuit will be like this. Solenoid, and capacitance.
R L J C.
And there will be, and we will see that we have L and R resultant
0% of the VL and VR.
resultant will be like this. Phi 90 degrees. In VL and VC, resultant will be between V equals to, this is the perpendicular of the base, perpendicular of triangle, and this is base, and this is hypotenuse. We have to find the hypotenuse, the resultant vector, resultant voltage. We will do the formula of P square plus B square under root P square. Perpendicular will be equal to VL whole square plus base will be VC whole square. For getting the resultant voltage, V equals to under root value of VL I into XL, value of VC I into XC a whole square कौन सा सर करना था एलसी सर भी होता है एलसीआर होता है एलसी होता है आई एक्सएल का होल स्क्वायर आई स्क्वायर एक्सएल स्क्वायर प्लस आई नॉट
because I naught is the maximum current of the AC circuit.
and we here will be I naught, as current will be maximum, then only we will get the voltage. I naught is the maximum current in the circuit, XC whole square. V equals to I naught square, I naught will come outside under root XL whole square plus XC whole square. We know that V by I naught equals to Z, which is known as impedance, which will resist the flow of current in the circuit. Meaning of impedance is it will resist the flow of current in circuit, as it is an AC circuit and it is an inductor and capacitor. we will get here, it is, we have derived the formula xl whole square plus xc whole square. This will go there. V equals to I naught equals to under root xl whole square plus xc whole square. V equal to I naught equals to z. So we also get that z equals to xl whole square plus xc whole square. The value of impedance in AC in LC circuit. In question, in exam we get the question, derive the expression of impedance. This is the expression for impedance, and the resultant value of voltage. This is the value or resultant value of voltage. In numerical, if we have the value of maximum current and the XL and XC, we can find the value of voltage and also impedance by this formula. This is the circuit we have to learn for exam, and this also. From here we can find the value of phi. Tan phi equals to perpendicular by base. Tan phi equals to perpendicular is VL by base is VC. Tan phi equals to VL I into XL by I into XC. I cancel. Tan phi equals to XL by XC. Value of XL is omega L. Value of XL is omega L, omega into L, by value of XC is 1 by omega C. 2 pi by T into L. Tan phi का वैल्यू निकालने के लिए ऐसे करेंगे XL upon XC. उसके बाद ऐड करेंगे छोड़ देंगे. In exam we will be given the voltage and current. So from this we can derive the XL and XC, and this will be the value of tan phi. From by putting the value, if we have given tan pi equals to XL by XC, any value we will tan, if it will be equals to tan phi equals to 1, then we know that from trigonometry 1 equals to for tan phi equals, then tan phi, if by dividing XL and XC we will get a numerical value approx, then after getting the numerical value we will use trigonometric identity and we will use it in the form of tan, then this will cancel and we will get the angle between them. It depends upon the question. If it is given, we find also the angle between the resultant and base.
X equal to X then T and phi is equal to 45 degree.
Yes, XL equals to, if XL and XC will be equal, then value of XL and XC will be equal, then tan phi will be equals to 45 degree. Phi will equals to be 45. Phi will be equal to 45 degree. We will remember this relation. Now we will study about another circuit. RC circuit. This we learned here this about this circuit. The next circuit we are going to know about. Only three type of circuit will be asked in exam in half yearly, and their derivation, expression and numerical based on the formula impedance. We have to find the impedance in each circuit. Impedance is the thing which resists the flow of current in the circuit. In this circuit we have two things: R meaning resistance. We all know about resistance very well. C is capacitance. We have learned this in chapter 2 in physics. Potential, capacitance and these things. The diagram of the circuit will be resistance, capacitance by voltage source. This is the voltage source or potential difference battery, we can also call it. We all know that V equals to V naught sine omega t by Ohm's law. V equals to IR. V equals to I into R. VR equals to IR in capacitance, potential difference across the ends. VC equals to I into XC. I into XC. Here also we know that X value of XC will be 1 by WC. W is omega and C XC. We will draw the diagram. By phasor diagram we know that current and voltage flow in this direction, same direction, VR, and in capacitance it will be flow in this direction, VC. Voltage will be more than current, so we know that the direction of current will be I here equal, same for both of them. Resultant voltage 90 degree phi. Here we will draw I into XC. VC equals to I into XC. We will give the resultant voltage VR whole square plus VC whole square. By the Pythagoras theorem we know that perpendicular by base, phi equals to perpendicular by base tan. Perpendicular is VC, base is VR. H equals to under root P square plus B square, under root VC whole square plus VR whole square. V equals to value of VR is I into R, I square by R square, plus value of VC will be I square into XC ka whole square. V equals to I will be outside as I square, R square plus XC square will be the thing which will be remain in under root. Now we will get the resultant vector as V equals to I outside by R square, plus we can also write the XC equals to omega C, 1 by omega C. This is the value of resultant vector, resultant voltage in a RC circuit. Now for impedance we know that value of V by I equals to Z. So here V by I equals to under root R square plus 1 by omega C. So we can also say that Z impedance will be equals to under root R square plus 1 by omega C. And here we can change the value omega C, 1 by omega C or XC depending upon the question. If we have given the value of XC, we will directly put the value of XC. If we have not given the value of XC, only given a omega, we will find C from here by putting value of XC and omega. We have know that omega value is 2 pi by t omega is 2 pi by t. As omega is angular displacement, this is 2 pi into, we can also write omega 2 pi into mu, frequency. This is the derivation. Hope you all understand. If you want to study like this, you have to take admission in JYOTI classes, because the teacher here are excellent and knows the what are the curriculum of exam and what will come in exam. I have learned this much and learned it in one day only. Sir has taught me important topics only. This all first I used to hate the derivation because I didn't understand it. But now I have learned it, as we know that if we in school, if we have studied, we have only studied this. The school will not teach this phasor diagram and we will always be confused that how it will be VR plus VC whole square. But in the coaching I have studied from zero level, so I understand everything here. So I hope you all like this video and thank you.
The next topic is circuit.
And yes, there is also one last circuit, that is the important circuit, very important circuit. It is the combination of all the material that we have learned till now, the LCR circuit. As we know that the meaning of it is resistance, capacitance and solenoid inductance connected by voltage, LCR. We know that in diagram we will get VR, VL minus VC, VL minus VC, 90 degree, here also VL minus VC. In resistance V equals to IR, capacitance V equals to I into XC, inductance V equals to I into XL. All the three we have studied before derivation. The resultant voltage will be under root, here in this triangle, tan theta, tan phi perpendicular by base. Perpendicular is VL minus VC and base is VR. We know that this we have to find the resultant voltage. So by applying the triangle's formula, hypotenuse equals to under root P square plus B square, we will get that under root VL minus VC whole square plus VR whole square. VL minus VC, we will write here VL minus VC whole square plus VR whole square. V equals to VL value I square into XL का whole square. सर इधर भी I नॉट होगा, I नॉट माइनस I नॉट whole square into XC whole square plus I square into R square. I naught will be outside, under root outside, I naught under root XL whole square minus XC whole square plus R square. This is the value of resultant voltage in the LCR circuit. This is the important value. We have to derive this value only. Now the value of impedance I naught V equals to Z. So Z will be equals to under root XL whole square minus XC whole square plus R square.
XL minus XC का whole square.
Yes, it is written here. We have found. So we will put whole square in both. XL minus XC whole square plus R square. This is the value of impedance.
यहाँ सबसे चल रहा है.
Impedance in LCR circuit.
अभी है, हाँ कितना दिन पहले बता रहे हैं आपको.
In LCR circuit, this is the well. Hope you all understand all the important terms of electromagnetic AC alternating current. 2 or 3 more topics are left, which is only the physical, the theory only which we have to learn, and the type of transformers. There are type of transformer which we have to learn, and then this chapter will be finished from exam point of view. As we know that every chapter has many topics, but we are only studying for exam now. As you know, Jyoti sir teaches all chapter freely with his free mind. He knows which topic will come. So for our exam half yearly, which have been given all the topic chapters, so he is teaching now the topic which will only come in exam, so the student can obtain marks from the chapter which he have not learned till now. In 2 days only you can learn this. I have learned this only one day, as this topic was taught to me today, and I have guessed the technique. So by looking in the derivation, I have remembered it in 15 minutes only, and the before that I have remembered it from yesterday. So I hope you all understand this. Thank you. I am student of JYOTI class near Gola Road, T Point Telecom Society, and there is also a branch near Gola Road petrol pump. Thank you, and I hope you all like my computer.
All students, good morning all of you. बाबू देखिए, ये स्टूडेंट्स मेरे बहुत प्रिय स्टूडेंट हैं. बहुत कम टाइम में इन्होंने मेहनत करके अपने आप को परफॉर्मेंस आपके सामने देखे. एक भी टॉपिक को आप नहीं देखे होंगे कि बुक रखकर या पेज में लिखकर आप लोग के सामने बता रहे होंगे. इसी प्रकार से आप लोग एक्साइटमेंट होकर मेहनत करें जुनून के साथ और अपने आप को प्रूफ करें. कोई स्टूडेंट बाबू हर चीज को सीख कर कहीं से नहीं आता है. मेहनत तो एक दिन आपको करना ही पड़ता है. जिस प्रकार से कम टाइम में अनुराग मेहनत करके अपने आप को प्रूफ किए हैं, उसी प्रकार से सारे स्टूडेंट मेहनत करें. देखिए एग्जाम के टाइम बहुत नजदीक आ चुका था और इन्होंने कहा सर काफी कुछ मेरा छूटा हुआ है. तो मैंने बोला बाबू एग्जाम पॉइंट ऑफ व्यू के हिसाब से मेन टॉपिक इंपॉर्टेंस कर लीजिए. मैंने इनको हिंट दिया, थोड़ा समझाया, और ये स्टूडेंट इतना मेहनत करते हैं कि आप लोग को बता नहीं सकते. इसी प्रकार से सारे स्टूडेंट को हम कहेंगे कि मेहनत करके अपने आप को प्रूव करें, और इसी प्रकार से मेहनत करें जिसमें कि हमको साथ साथ आपके मम्मी पापा को भी गर्व हो और आपके ऊपर प्राउड हो. इसलिए थैंक यू ऑल ऑफ यू, धन्यवाद. इसी प्रकार से आप लोग पढ़ते रहें.